Hey guys, good morning. Uh, it is actually Monday morning, first thing. Hey, I got this new microphone and it is super sensitive even when it's turned all the way down, so you'll probably hear all sorts of background noises. I went back to my bedroom to try to get away from stuff, so we'll see how that works. Anyway, I hope you guys are all doing well. I know this is really frustrating, but I really do want to make sure I give you what you need. So, again, please don't hesitate to shoot me a text or email or something. I've got I'm going to look at a couple problems here that some students have asked about, but I think would also be a good review and lead up to chapter 24 as well. So here we go. So this is number 35 on chapter 22, I believe. So we got marriage, 1960. Let's see, age at which American men first married had a mean of 23.3. It's widely suspected today that people are waiting longer. We want to find out if the mean age during the first marriage has increased during the past 40 years. Okay, so I'm going to do this, and I don't need something that thick to write with. Let's see if we can make this. There we go. Okay, so age 0 would be the, oops, we can write in words, that's fine. Mean age at marriage. Oops. For men. I'm like having problems here. You know what? I'm not going to write it out. We can write it out, but we don't need to. So let's just do it like this. This is good that you see this as well. So let's do mu is the mean age of marriage for men. And so that's what we're looking at. And H0 would be mu is 23.3, and we're going to look at data and see if it's actually increased. So if it's greater than 23.3. All right, neighbor dog's barking in the background. You can probably hear that. Neighbor dog barks, my dog gets excited. Oh boy. All right, okay, so we've got this. We're going to do, this is a one sample t-test. Okay, so there's my hypothesis. We're going to test it. We're going to get a random sample of 40 men who were married for the first time last year. Okay, so we're going to look at the conditions. Just make this smaller so we can keep it on the same screen. Conditions. So this right here is the first part. Second part would be conditions. Sample is random. It's given. Number 2, let's see, n equals 40 is less than 10% of all married men, the population. And thirdly, n is 40 is greater than 30. So by the central limit theorem, we are okay to proceed. Okay, so there's my conditions. Okay, C, the sampling distribution model. So the distribution of all samples looks like this. We don't have to write this, but we need to be aware of it. So mu of x bar is 23.3, because that's what we assume is true way up here. And the standard deviation is my sample standard deviation divided by the square root of n. Okay, so this is going to be normal, or we'll say approximately. We should always use words like approximately. Normal because the conditions were satisfied. Okay. Now in D, they tell us in the sample the standard deviation is 5.3, so this would be 5.3 over the square root of 40, right? Because that's my sample, that's equal to S. And that right there is my X bar, my standard, my sample average. Okay, so if I go to 24.2, the p-value is the probability that my average is greater than 24.2, because remember, this is the X bar distribution, right? So that's the p-value. what is the definition of p-value? You've done this a few times. We said it's the if mu is equal to 23.3, that's H0 true. If the defendant's innocent, kind of thing, the p-value is the probability of getting a sample mean greater than, as extreme as 24.2. Okay, that's this area over here, bigger than 24.2, which is all of this. Okay, so that's the p-value. That's what it means. Okay, so my conclusion is I'm going to go ahead and do the test, and I'm going to find the t-score, because it's a t because I'm using the sample standard deviation. I'm going to do this on my calculator. So I got stat test. This is a t-test. Stats. So mu 0 is 23.3. X bar is 24.2. S is 5.3. Probably can hear my clicks on my calculator because this microphone is so phenomenal. You're probably going to hate this microphone because you're hearing my breathing and all that stuff too. I don't know. So greater than, there we go. Okay, so if you do this, we got t is 1.07. So only 1.07 standard deviations away, so that's probably not going to be that extreme. The p-value is 14.5%. Okay, so me getting a 24.2 sample, if the population is 23.3, the chance of me getting a sample of 24.2 or greater and a sample of 40 is 14%. So I'm not surprised at that. Okay, so I think it just could have happened by chance. So since 14.5% is greater than 5%, I don't have evidence that the mean age at marriage is larger than 23. .3 years. So I don't have evidence that it's gotten increased. Okay. And now you always want to go back and make sure you answered the question that's being asked. In this case, we want to find out if the mean age has increased during the past 40 years. So I don't have evidence that the mean age is larger than 23 years. I want to answer the question directly, i.e., no evidence that it has increased since, what was it, 1960? Yep. Okay, now I'm specifically answering what they asked, okay? Just something to kind of keep in mind when you're doing these problems. Okay, so if you have questions on these, please let me know, and I will do my very best to answer them. And we will be having some Zoom meetings more often than, well, I'll be available a lot, so that I want you guys to be able to have access to me as much as you need. Okay, here we go. We'll go to the next one.